Hey guys, how's everything going? This is Jaser. If you are on Twitter, you know that React is on fire. I mean, people are starting to bash uh, at React implementation, internal implementation, especially the fiber tree, aka the virtual DOM. Well, it's not technically the so-called virtual DOM anymore. But anyway, the SolidJS and together with some other framework library authors claims that they have better reactivity comparing to React, and it's more performant. It's better. Developer have better DX. As a noob engineer, I cannot tell which is right or wrong. I guess in this world, no one is absolutely right, and it's just a balance of cost and gains. But for us, the best we can do is try to understand their claims, right? For React, I've put up over I think 26 YouTube videos about its internals. If you're interested, search on my YouTube channel or just to visit the blog post on my jso.dev. So in this video series, I want to take a look at SolidJS too. So the first episode, SolidJS Source Code walkthrough 1, but actually we don't touch any source code about SolidJS yet. For this episode, it's just a rough guess from our perspective based on the SolidJS syntax and some supporting materials from the author, Ryan. He had this fantastic post about how reactivity works. If you prefer the original one, just go for it. For my part, for my blog post, I think added my understanding and extra part about the compiler stuff. So yeah, this is about first look at fine-grained reactivity. Solid claims that it's performed because it has fine-grained reactivity. Yeah. Now, first of all, how React react? I mean, how React, how the reactivity of React works. I think I've covered it in my YouTube series, and to summarize it, React has an internal tree called fiber tree. So each fiber, if it is its state, usually it's from the state hook. If state changes, the fiber will be marked with something like, okay, we need to re-render. And the interesting part is that even though one node is marked as needs to render, the full re-render from the root, you think of it as a tree. Basically, React re-renders the whole tree. Well, of course, some untouched subtree, so it will be just skipped for obvious performance reasons. But still, the root to the updated nodes, the nodes will all be re-rendered. They will have some performance issues if you don't use the memo, use callback enough. But for most of the time, I think we can ignore them. I don't care about performance actually in my daily life. Anyway, React re-render is by re-render, we mean that it will go to the marked node and compare its current state and the future state, and then diff them, and then decide whether it needs to be inserted to the DOM or updated or deleted. And then after everything is done, we create a new fiber tree. The effects here in DOM manipulation are reflected. So, the best of all is that the basic thing we need to remember is that basically React re-renders everything unless you do some performance tuning stuff. And Andrew Clark, the author in React, said in his tweet that React wants to keep this mental model is that you don't need to care about you can just pretend that we just re-render everything, like you're building some server backed apps, like you're using PHP. You just re-render, just output the HTML and browser will just re-render for you. You don't need to care about which part specifically you want to update, right? And this, I kind of agree that this gives us a easier mental model. I don't need to care, so I just pretend everything will be re-rendered, and it's not super performant, but it's okay. Then yeah, I just get my job done. But the one thing about hooks, right? The hooks, people say it's good, it's super powerful, yes. And after working with React for I think 5 years, I still think well, when I started it, there were no hooks yet, but the hooks actually are indeed a pain in the ass. To be fair, I've put it out this a lot of times in my videos. Is that the hooks is just the internals of React is so complex that I don't believe that you can use it properly without understanding how it actually works. You can probably use it and it doesn't harm with normal usage. When it comes to the trickier cases, reminder stuff, it just blows my mind. Okay, cool. So this is how React. Let's take a look at Solid. Here's the basic counter example. It's right here. I put a link. This is the Solid playground. This is a counter. When I click it, it just increments itself. Let's look at the syntax. This is the create signal. This is kind of similar to use state, right? This is initial value and count and set count, and the increment is set count +1. So far, similar to React, and also Solid supports this JSX syntax. This is JSX, yeah. So far, everything is perfectly similar, except one thing is that for the count, we need to use it. This is a function. This is getter function. We need to call it, execute it to get the value, and also here we need to execute it, and also render here. We just not render the JSX directly. We render this renderer function. Yeah. So this is the slide or the most critical difference against the React. Well, we'll soon know why this is the case, why this is needed. So from this code, we think that, yeah, this is interesting. Without the virtual DOM, how would we implement it? How did this fine-grained reactivity work, right? So I think, okay, yeah, if you prefer the original post, just go there. I put a link here as well. There are 3 problems we need to solve. The first one is how to notify others when this count changes, right? And the second thing is how to subscribe the changes. So like this is an event emitter. How do you emit the event? And this one is how do you subscribe the event? And the third one is how do we use this subscription to update the button text, the text here. So these are 3 questions, and the code below is just some rough code for demonstration purpose. Do not use it, and I've also put it in my repo. It's called onSolid. Yeah, there are all the code we can refer to. So yeah, the first thing, how to notify others when the data changes. We've already seen the syntax like this, and we already know that count is a function return the value. Set count is a function that accepts the value to be passed as the argument. So obviously we need to return a getter and a setter. For this function, we hold this value. This is initial value. Getter, return the value, a setter. If the value changes, we notify. So this is it. So the first question is very easy. The second one, how to subscribe the changes. Well, this is a bit slightly harder. Is that when we want to subscribe the changes, you can see that from the syntax here, there is no direct command, right? We just obviously we can only subscribe when this count is executed, right? When it is executed, we need to subscribe the change and update the button here. Yeah, so obviously for this create signal, we need to hold the subscription internally as well. So when this getter is called, we need to subscribe to add the callback, but we'll come right back at where this callback is set. And for setter, if the value changes, we will just trigger all the subscription. So yeah, simple. Now one thing for count is that we see that there are 2 places count is used. The first one is increment, and second one is in this JSX. They're actually different. For the count here, we don't need anything to be reactive here, right? This one is purely want to get the value, pure value, while this one needs to be reactive. So the thing is that we need to make it explicit about whether we want the reactivity or not. So from Solid, this is one of the reactive I think API is that create effect. So when created effect is passed with a callback, once the callback is executed, all the dependency will be collected automatically, and anytime the dependency changes its value, the callback will be triggered again. So the final effect is something like this. We have a counter, we create a signal, and we will increment the count every 1 second, and we create an effect, and it will log the count here. And let's try it out first. So if you open the console, you can see that the count update, the log is printed every second with the incrementing number, right? So this is the demo. So for this to work, for create effect, when we run the callback, we set a global variable with this context. Well, when it's done, we need to set it back. So we use this prev context to get the context, sets the context callback, and then sets the back context back. So this means that when this getter is executed, we can get the current context, right? The callback from this context variable. And then if it is not null, we can be sure that, okay, this is the context subscription we need to do. So we subscribe it. And yeah, so this is the piece of code that makes this work. Yeah, so the second question is also answered. The third one, how do we update the DOM properly? So you would think that, yeah, actually we can just replace this part to the DOM update, right? Yeah, simple. So for the counter, for the initial render, we could just create a button and set up the event handler, and then return button. This will do. But for the update, we just needs to add this line of code. Create effect. So the button text content is count. So every time count is updated, the button text will be updated as well. So let's take a look at the example. This is all the same code, and then we click it. Yeah, you can see that it's increment itself. The logic I've already explained. When this create effect is executed, the callback will be passed to the count, this single subscription, and it will be run every time when the count is changed. So this is basically what fine-grained reactivity mean. You can see that when the initial render is done, the dependency, this one, the dependency will be collected. So anytime the dependency, the signal changes, the places where it is actually dependent upon, it is used, will be updated accordingly. So different from React, which re-render the whole tree and try to skip the untouched nodes, this fine-grained reactivity means that we just target the single nodes and nothing more. If more nodes needs to be updated, then these nodes are actually depending on the signal, so it will be updated automatically. It sounds really performant, right? The only question is that this is not free. We need to maintain set to hold the subscription, and also this one piece of puzzle missing is the cleanup. I think for the DOM to be dynamic, we need to clean up the subscription somehow. But that is out of this scope of this video. We will cover it later while we're diving into the real source code. So yeah, but the one question left is that we don't see this line of code in our demo, right? In the SolidJS demo, like here. Yeah, we don't have that, but still it works. How did that happen? So actually that's a very important part of Solid is the compiler. The compiler will compile the JSX code and add, and together with some code from the runtime, it would add those effects calls automatically for us. So how does that work? Don't worry, let's continue. So first, for this piece of JSX, if you are familiar with React, you know that it is something like this, right? Like type, button, props, children, because this will be evaluated when this expression is JSX element is created, so it will be primitive number value, something like this. And then together with the runtime, they will try to, say type button, they will create a button, and prop, set up the prop, stuff, blah, 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 like this. Yeah. But if you want to make it reactive, this definitely not gonna work because this is primitive value. We cannot get the dependency like this, right? So when this JSX is created, this will be gone. This will be just a primitive value. So no matter what you do, you don't have these. You don't have the clues connecting from this count call and to this number. What we can do is actually wrapping this JS expression, wrapping this count to a function, and have this convention that during the runtime, if we meet some function, and then we execute it, like lazy delete the execution, and then get the value and just continue rendering. By these. By doing this, we can properly set up the context and make it reactive. Remember that for the create effect, there's a call here, right? We need this call here right after the context set. So this cannot be some primitive values. Yeah. So how do we do this? Yeah. Well, we need to. Because this is not default behavior for JSX transpile, I think in Babel or something. We need to transform the JS code by ourselves. I think this is yeah. So our goal is for the piece of code like this. We want to transform into something like this. Create a button, set the event handler, and create insert. Why we insert here? Why not we just update the text node? Is that we don't actually know what is inside of this count. For here, we know it's signal, but purely from this JSX, this count could probably return some other JSX elements, right? So we cannot achieve this reactivity without runtime code. We need to this insert. Like a bridge to the runtime code, and this insert might run the function, and it is JSX, and we need to recursively call this insert. So this is for the JSX transformation. We just use the insert for the JSX expression, meaning the things between this curly brace. So for the insert, we did lefty to do. For insert the element is function, we execute it. If intrinsic elements, for like a string of p button, we just create them. If it is primitive values, we treat them as a text node. So basically for everything that you can see on the screen, if it is dynamic, it eventually end up in text node. I think. It's pretty straightforward, right? If you want a dynamic, it must be some text within some other elements, button, span, or anything. If it is native, if it is HTML elements, we just append them. So this is our goal. This is kind of like a programming, question, right? Our goal is clear. What we want to do is just to transform this code to this code. Then what do we need? We need the AST traverse. If we open the AST Explorer, this is the code we want transform. If you can see that in the return element for the JSX, we actually got the JSX element here, and it has opening element and closing element. For opening element, we have this attributes. We have 2 type on click, and also children. We have 3. This one is the empty space, and in the middle is the JS expression container, and inside of it we have this call expression. This could be something different, like +1, yeah, call expression, right? Then this is binary expression. Yeah. So so this is what we have. It's actually not very difficult. It's just very tedious because I don't have much experience doing such things. We can use Babel parser, which is to parse the code. Yeah, parse the AST code into AST, and then we traverse. We walk through this AST tree and do the necessary chain modification. Template is something help us create those this AST subtree. It's just some helper. Types is also some helper. And then finally, we want to generate the JS code. We need this Babel generator. So yeah. So this is some template like the IIFE. And this is create a child. This is create node, blah, 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 insert. So yeah, this is important. Insert expression. This is just a placeholder. Yeah, blah, blah, blah. If you want to take a closer, just to look at it. So the core, actually, you can see that for the traverse, we have put it here. For our demo, we will get all the files on the demo and then read them and then compile them. For the compile, we parse it, and we need to enable JSX plugin and traverse through it. For each JSX element, we will replace the AST node after transforming it. And then we add the insert call and then return, generate the code. So and you can see that the magic lies into transform JSX elements. Inside of transform JSX elements, we do it differently. If it starts with lowercase string, it's intrinsic HTML elements, and otherwise it's custom elements. Because for custom elements, we don't actually know what it returns, right? So we can only inject the insert call to let the runtime do it for us. But if it is intrinsic, the HTML elements, we know that we need to return an HTML tag. So actually, we can create the container and append the children. And so let's take a look at the intrinsic elements first. So for example, for this kind of JSX, we want to return a IFE call and create a node with P. Obviously, it's P, and return the node. And also, we need to append this one, right? Append this node. This node is JSX element as well. So it's kind of similar to this one. This node 1, we need to count it to give it an arbitrary name, unique name. So this, you can see that this is actually similar to this one. Inside of it, we create a button, and then for count, this is dynamic expression. So we use insert and then return it. So simple, right? So let's see how we do it. We get the type name, get the children, and for each children, if there's JSX element, we just recursively call the transform, and then create a child with node count. This is just an incrementing count is to generate the identifier like node 1 or 2 to avoid conflict. So you can see that we just create a child. This one is create a child. And then append child. This one is append child. And this is the JSX element. If this JSX expression container, as we said, we just insert add the insert call. If it is JSX text, we know that is text node. So we create the text node and then append it. And the one thing is about the attributes. We get the attributes from the AIST, and we set up the attribution setup a call. Basically, I haven't added the node here, but it should be something. I think it's somewhere in the compiler here. At least you can see for this main. Okay, here we would generate something like this. This one is the attribute call. We set the type, we set the onClick. Cool. And for the custom components here, like this, as we said, we don't know what it is, so we cannot return a container node. We just transpile it to normal JSX the compile result, just called execute the function. So the whole structure is similar, but for the children process, we need to pass the children to this children props as a argument for this T function for this component. So this will be simpler. There's no real DOM creation. We just return the expression. Cool. And yeah, that's it. The only part that needs to be pointed out is this insert call, how we handle them. For JSX expression, we insert this expression, wrap this expression with this arrow function. So you can see that how count call becomes an arrow function, right? Because we did it here. Yeah, it's basically transform this count into insert this. Insert is from the runtime, which is DOM.js. We'll take a look at the DOM.js right away here. So for DOM.js, we have two functions. One is render, which is the initial entry point. With this is oversimplified, we just insert the renderer here. For insert is kind of big tricky because don't trust this code. This is just for demonstration purpose. So I have this assumption. I assume that the nodes are stable. So for each part of the children, they all return an element. Even for null, we will use the empty text node to work as a placeholder. So for each child, for each element, they will use a real DOM node to hold them. So that we have, because of this stable, because the index is stable, we can use position to target the rendered node. Why? Because for the initial render, we can just append them, right? Append them. But for the updates, we need to be sure to target the previous render node, especially in the create effects, right? For the initial, we just insert it, but for the update, we cannot just update random nodes, right? So we need to get the for the initial insert, we get the position, and for the second one update, we get the position and just insert it, and insert it, call insert again, because this time the position is passed. Actually, it will not append but replace. So yeah, I think this is pretty straightforward for insert. Together with this, we are able to have some working compiler example like this. This is, yeah, you can see that click it, it's working. And for main.js, we can create something like add two button, like div two button, like we compile it, npm run compile. It will build the main.js for us like this. So you can see we create a button. Oh, this is counter. Oh, inside of the counter. This is inside of counter. Node 1. Wait a minute. Oh, we have forgot to save it. Shit. Cool. Now you can see we have two buttons and they both be reactive. Let's see the build code. You can see that for this node 2, this first button, and this is the second button. And inside of it, this is a text node, right? Empty space text node. And also for this expression, something like this. Yeah, that's pretty much of it. Yeah. And this is final demo. This is final. Okay. The link is something broken, but update it right away. Or you can visit the repo. There's also a demo there. You can clone this repo and just fiddle around by yourself. Here is the demo. Increment by 1, increment by 2, and this was dynamically. render a bold text if it is even number. And so if we take a look at the code, this is main. No, it's demo main.js. So yeah, here, if it is even, we return another JSX, but the runtime, the insert will handle this nested JSX element perfectly for us, and otherwise we return a string odd. This will be treated as text node. Let's see how it is compiled. Remember this input, the file. Yeah, this is all the files. And for the build, let's take a look at main.js. Well, it's pretty long. So I think there's a. So I think this is not cool. There's too many DOM call here. I think this could be moved to the runtime as well, to help avoid the DOM to be bloated. Anyway, we can see that here, insert. This is the call, right? And this one is how we change it to the DOM creation. Before it is JSX element, and also we add this arrow, make it arrow function, and we insert it. Cool. So this is it. Summary. Yeah, we don't touch any solid source code, but we managed to have a vague image about how this fine-grained reactivity works, right? I think it's pretty interesting, and I'll continue investigating into the real source code, and hope it helps. Stay tuned for my next episode. Bye-bye.